Okay, now I can start a new drawing. Now, please pay attention. I'm just going to show you how to do a project. Okay, now, where's the project manager? Should be here. What does? Cannot see my screen? Okay, hold on a second. Why is that? I said, oh, it didn't share. What's going on here? Stop showing feature screen. Do you see it now? Can you move the screen around? Huh? Yeah, okay, that's why, because this one is different. Let me try again. So we just stop this sound for a while. What about now? Okay, now you can move it, right? Okay, good. There's no need to share this because you already, oh, he needs to, Mr. Mahmoud. Okay, Mr. Mahmoud, you can see, right? All right, so bear in mind, okay, if you don't see this, there's also a project tab, but you cannot have this project manager until you have at least one drawing active. So I'm going to just start a drawing, any drawing, it doesn't matter. And now, where's my project manager? It's not here, so I have to activate it. There it is. This is the project manager. Okay, now, here is where I say new project. Follow with me. Okay, this is what I say, new project. Okay, now it says, what's the name of the project? Let's say lab, for me at least, lab 5, class demo. What are you missing, Basan? What, you have a question? Of course, now that I'm recording, people are shy from asking questions. Don't, okay, it's just normal class. There's no what? You don't have project manager on your screen? Well, okay, now, do you see project here? Okay, go to it. I'm just going to cancel this. Go to project, and there's project manager in the very beginning. So if you don't see project, here is another way. Okay, if you don't see project, because AutoCAD allows you to control how many tabs you get. So go to any place which is empty and right click, and then go show tabs. One of them is project. Make sure it's clicked or checked. If it's not, check it, and then you will see project tab. And also this one is called the quick launch toolbar. Also, you right click and you customize. And then you can add stuff to it. But there's always more than one way to do the same thing, right? So everybody sees the project manager now? Why not? Do you see project here? On the menu. You don't see it. Okay, go to some place empty with your mouse, Mr. Burhan, and right click, and then go to show tabs. This menu opens up. Go down until one of them is said is states or shows project. And make sure it's checked. If it's not, just because if I check it now, it takes it out. There's no more project, even though I can take out schematic and so on. But if I want to put it back, just go back, and then now it's not checked. Just click it once, and there it is. It's back again. Do you get it now, Mr. Burhan? Go help him, Harun, please. Okay, so now I'm going to say plus, which means new project. And I'm going to say lab 5 class demo for me. Now, location. Default location is on my documents. But as always, put your stuff in a known location on your Z drive. So you can say browse. Right. In my case, actually, I'm using OneDrive. Documents, CNA, this guy, and then EG, then labs, lab 5, and I can create it there. Now, yes, you should get this. It says create new project. Oh, did you click this green? Here I'm canceling again. You see this green? Click it. This will open up this window. Do you have it? Okay. One more time. Lab 5 class demo. For you should call it Lab 5 practice. Don't call it demo until you are ready to demonstrate. And then when I see you, call it demo. Okay. Then you say browse so that you can locate it where you want to put it in your Z drive, because Z drive can be accessed anywhere. Of course, if you have a OneDrive account, you can also save it to the cloud, which means you can have access to it anywhere, even at home. So in my case, I'm going to put it into EG and then labs, lab 5. This is fine. We'll say okay. Copy settings from project. It might be empty, right? Or just leave it as default. And also, if you see in the tutorial, lab 5, it says, okay, properties. What does this do? Any settings you place here will be copied to any new drawing that you create or add to the project. So some of the things that we're asked to do, for example, is the width. Huh? No, the spacing is 1.5. Okay, well, spacing. Also here, you can make it 1.5. And this one was what? 15? 15. Right? Of course, these are settings that will save you time if you want to use it repeatedly in different drawings. But if you leave it out, you can still force it in individual drawings. And then we'll say, okay. The value you have entered to the spacing field is not properly formatted. More than one dot, this guy. Okay. One more, okay. Why don't we just do it like this? How about that? There we go. Now I want you to notice what happens now. Do you have it, Mr. Burhan, or not yet? Missed what plus sign? This one you mean? Not yet, because we haven't created any drawing. So you will not see a plus sign. Now it's not, it's empty. It's a project shell, but I want you to pay attention to the project shell. Burhan, you still having problems with the project or what? Saving, yeah, save it on your Z drive. Do you have your Z drive? Okay. Your face shield, Mr. Harun. Basant and Sama. Your face shield. Okay. What I want you to do now is go to the place where you have saved the project folder. This process creates a folder in your Z drive, wherever you placed it. So I'm going to go, in my case, I'm going to go to OneDrive and show you what I have. So I'm going to go here, EG, here's labs, lab 5. And you see, there's the class demo that I've created. Open it, and you'll find there are 2 files. These files, never touch them. They have all the settings of your project. Okay. What? No, you've created a folder. The folder, if you said, halas, if you said okay to the, and you've seen the title here, then it will be. Okay. I mean, what you're saying is not possible unless you have this at content. This is my screen. Where is your where did you put it? Huh? No. Look at the project properties. And okay, I'm going to forget this. And I want you to create a project in front of me now. Do it. Lab 5 practice. Be proud. Okay. And then, okay. All right, now, go here now. And lab 5 practice. No, you missed a step somewhere. So you put it somewhere else. You think you would. These are the files that I'm talking about. So there are 2 files. Everyone finds the 2 files? Okay. Now it's still an empty. It's still an empty project folder. Empty except for those 2 files which have settings. All right, now I want to say right click and then new drawing. Right click on the project name that you have created. And you're going to say new drawing, right click, new drawing. Now let's call it lab 5 schematics, schematic diagrams. I think there's a particular name that is called for in the instructions, right? Actually, it's not just schematics, it's schematic and one line, but let's call it schematic diagrams. Template, never leave without specifying the template. Which template? You can use lab 4 or we can use the ACAD electrical. What's the difference? Well, if you use lab 4, you already set your PDF and all that stuff, right? But if you do this, you have to go and do the settings. Does it matter? It doesn't. Well, except it saves you some time. If I go to lab 4, for example, in my OneDrive, here's lab 4 template. Double click it, and there it is. Of course, now you can put some descriptions. You can put how many sheets you have and so on. And then you can also go, okay, properties, if you want to change properties for this particular drawing. Not project-wide, just for this particular drawing. And then it gives you the same as before. Okay, now here are the properties. Again, you can change them. It adopted the project properties that I have entered. Okay, when you're finished, just say okay. Okay, now notice I didn't see anything here. Sometimes yes, sometimes not. If you don't see it, you need to click on these 2 green arrows, refresh. There it is. So I have 2, notice I have 2 drawings now. The one drawing here has nothing to do with the project, so I can close it. Right? And now this is my drawing. And look at the layout. It's already set for me. Don't need to do anything because I already used it in lab 4. That's the reason why we need to know how to do templates. What's the reason? What is the purpose of templates? To save time. Certain settings, like in our case, set it to PDF, set it to A4 or to A3, set it to portrait or landscape. Halas, it's done. You don't have to keep reinventing the wheel every time. واضح? Okay, now let's go to the layout tab. Of course, everyone should see the model and layout tabs here. If you don't, how do you find them? Anyone? What's that? Right click anywhere empty, right click and then go options and then go to display and then make sure this is clicked, checked, and then okay. Or you can also do it from here, from options right there. Same thing. Same thing. Whatever works for you. واضح? Now let's do the circuit builder. Go schematic, circuit builder, and then here are the automatic circuits that can be done. In our case, we're doing this. Horizontal, not vertical. Horizontal full voltage reversing. That's the meaning of FVR, full voltage reversing. And this one is what? FVNR, full voltage non-reversing. You guys took motors, right? What's full voltage? What's that? There's another name for it. What's full voltage, guys, from your motors class? Mafi. I haven't finished yet, but I'm going to choose this one. Full voltage reversing. But I'm asking, what is the meaning of full voltage as far as motors are concerned? It's called full, huh? No, it's called full, Mafi load, no. This is full voltage starting. Are you guys taking notes? Where are your notebooks? When you say this motor is full voltage, you mean it's full voltage starting. There's another name for it. In industry, it's also called DOL. What's DOL? Direct online. Yeah, direct online. You need to know it. Like 1 + 1 = 2. Direct online, DOL. Why do we do that? What is the other way of starting motors? Mr. Burhan, what's the other way? You're looking at me like you're wondering. Huh? No, there's another name. You took it in your motors. You finished your motors course or not yet? Yeah? Okay, what happened to the information? What? It's called reduced voltage starting. Full voltage or reduced voltage, RV. What is reduced voltage? How can we do reduced voltage starting for motors? What's that? What's burned out? Mafi burned out. No. This is a, why do we need reduced voltage? What is reduced voltage? Yeah. لا ما في damage equipment. We're reducing the current. Yeah, but the equipment is rated for that inrush current. It's not for the saving the equipment. How do we do reduced voltage starting? You said the resistance. Yeah, yes. Star delta, Y delta, or auto transformer. Very good. That's good. Mr. Burhan is still looking at me like, you took motors or not? Mafi. So very important. Reduced voltage starting. Why is the star delta reduced voltage starting? We start with the windings. The windings are configured as star or a Y configuration. That means the applied voltage, the windings, each winding of the three will see line to ground voltage, which is the line to line divided by √3. Like in this building, we got three-phase supply, 415 volts, right? So divide by √3, you get 240. You're reducing it all the way from 415 to 240 per phase. And then when the motor is running, it goes back to delta, so that each phase is getting full line-to-line voltage. Why do we do this? to reduce the inrush current, not because of protecting the equipment. No. What's the purpose of reduced voltage starting? Write it down, Mr. Azhari. Mr. Anamol. What's the purpose of reduced voltage starting? Huh? The what? No idea. Okay. Mr. Harun, write it down, please. And Basant and Sam are so far back, and there's plenty of benches here in front. Okay. Reduced voltage starting is particularly required or used, or may be required for large size motors. Why are they required? Because without reduced voltage starting, the inrush current can affect the it can affect other equipment because when you're starting a large motor, it's going to pull very quickly on the system. If the system capacity is limited, it's going to reduce the voltage more than 2.5%. See, this is the rule of thumb. 2.5% is the rule of thumb, that voltage should not exceed 2.5 or maximum 3%. What happens then? See, if you don't control that, you might cause tripping of some motors that have under voltage protection, like submersible pumps. In fact, I've experienced this much. I'm aware of in my work in the oil industry. We had a project where new gas compressors were added to an oil field, and when they came to commission the compressors, suddenly some submersible oil pumps tripped out. Why did they trip out? When they looked around, they said, "Oh, there's a voltage dip. What happened?" Well, it's because it's starting the compressors. The compressors were started direct online. They pulled the voltage too much. Because when you look at oil fields, they have local stations. They're not connected to utility. So utility sometimes is called the infinite bus. You have huge capacity available. So it's like you have a big tank and you take a small load, it's not going to affect the level. But if you have a small tank and you have a big pipe and you open it very quickly, you're going to see the levels drop. Same thing with generators. All right, so this is now, if I say insert, now it gives me this, click. And now just watch it build. And now you might get, be careful, guys. You see what the distance here between the phases is because I set the project to 1.5 instead of 0.5. So even the circuit builder will take these settings. Okay, what else do I have? I have a single line diagram. So I go back to circuit builder. And if I go down, one line motor circuit. Again, I'm looking for full voltage reversing. Insert and then place it and watch it build it automatically. Okay. Now, notice, well, you should understand this by now, right? This is full voltage reversing. This is the starting push button, right? And this is forward start, and this is reverse start. And we have, how do we reverse the rotation of a three-phase motor? Huh? Huh? Yeah, or changing any two phases, interchanging any two phases, right? If you look at these, so you got two relays, one relay for the forward, another relay for the reverse, right? And if you look at the contacts, you will find that this one, what does it do? This one exchanges, huh? 1, 2, 3. What right one? What right side? What second relay? This is the second relay. This is the reverse. What is? These are contacts, Right now, this is phase A, phase B, phase C, or L1, L2, L3. So right now they're going straight to the motor terminals. But when we go, when these are open and these are closed, then what happens? Phase A is not going to go through. It's going to go here through this contact back to the third terminal instead of the first terminal. Are you with me, Mr. Azhari? Okay. Now the second one, what happens to the second one? In the case when it's forward, it goes straight to the second terminal. And what happens in the reverse? Well, it goes back to the second terminal. So this one is not being interchanged. Whether it's going through this contact or this contact. What happens to the third phase? Yeah? Third phase, again, if it is in forward, it's going to go straight to the third terminal. Right? But if it is going through the reverse relay, it's going to go what? From the third phase to the first terminal. And that's how we are interchanging two phases of the motor. Obviously, we're not interchanging the phases of the supply. The supply is the supply. You don't change it. Well, now, one thing you want to be absolutely sure of is that you don't want these contacts to be closed at the same time. Yes. Why do we need that, Mr. Anamo? Huh? Why? Why not? What happens if we do? Short circuit. Between those two phases that have been interchanged, it's a short circuit. So that's why we have these interlocks. Where are the interlocks? These guys. See, this belongs to this reverse, and this belongs to the forward. So if this is running, and this is active, this will be open. So if the operator presses this button, it's not going to start, it's not going to energize the reverse contacts. And vice versa. If we're going into reverse, this will be energized and this will open. Well, you understand these symbols, right? This is called what? Normally closed. And this one is normally open contact. Any question? Now notice we need to go now and start entering the materials, edit component, and then motor. I think it's called motor one, right? Where do I find the materials? Well, if you look at the lab instructions, at the end, there is the material list, which is what you're going to create. So the motor, where's the motor? Here's MOT1. And there's the motor code, if you will. You can copy it. There's a lot of numbers and letters, so you can copy it. Or you can write it if you wish, right? And then here, it says motor one, here it says MOT1. Okay, we can make it MOT1. It doesn't matter. The tag, this is the tag of that motor. So I can change it. It doesn't have to be MOT1, right? And I think it's also here. It tells you what to do, right? What are we going to call it? Cover sheet, AC motor drawing, and so on. You need to make sure you include these. So you can say what? 3-phase motor, I think, right? 3-phase motor. And notice I put, on purpose, I put them all small. Notice what happens when I hit the tab key. It will always capitalize. Will always capitalize. Again, you can find this label right on the drawing. See here. See, MOT1 3-phase motor. This comes from the catalog. You don't need to enter this. 3-phase motor. Okay, now let's look at lookup. So we'll click on lookup and we'll get this. I can delete here and then paste my number, hit enter, and there it is. There are 2 of them. Just take the one that matches. It didn't actually copy the whole thing, did it? There was an enter. This is what we need. 218 VNC. VNC, that's it. And just say okay. Halas, and then we'll say okay. Map, don't show this again. Yes, map, no problem. Okay, there it is. Yes, update, no problem. And this one, I can also move it closer, like that. And of course, you have to do the same thing for everything. Do what? For the motor? Okay, let's delete it. So I'm just gonna Control Z until we're back. So you come to the motor until, see, when you put your mouse on the motor, it becomes bold. At that point, right click. This menu is only available for smart components. What is smart component? You've seen that in previous lab, right? When you have a smart component, if you drop it on a wire, it will automatically connect. When you delete it using the delete command, not the delete on the keyboard. When you use the delete command for smart components, it reconnects the wire. Watch this carefully, because in subsequent labs, we're going to be doing custom components and they have to be smart. How do you know they are smart? By testing them like this. If you use the delete key, it's going to leave a gap. It doesn't know, just deleted that component. So we're going to say edit animal, edit, and you get this. You can change this to MOT1. This one doesn't change the case. So MOT1, if you want it to be capital. And this one, we're going to say 3-phase motor. And then lookup. Are you with me, Animal? We're going to look up and then delete this. Unless, of course, you can scroll down as well. You can scroll down. Or you can just paste what you copied and then choose this one. Double click and then okay. Notice it has populated these boxes as well. Manufacturers AB. What's AB? Allen Bradley. And there's the catalog number. In fact, you can look up this catalog online. You will find the information. Just look at this number. Okay, we'll just say okay. And there it is. Yes, update. And this guy, what's that? Just say okay. Just map it and then click also, don't show this again. Yeah. Okay, you need to do the same thing for everything. Now I want to show you a few things, other things. Every one of these components has a catalog number. So you have to go through them one by one. What else do I need to do? Now look at this. See, this one line diagram is basically the same, right? It shows the forward and the reverse. But suppose now I say, well, this is too close. I want to move. And guys, always, I'm reminding you, you don't want any text to cross with any line or any component. So you can see here, suppose I want to move these lines a little bit to the right and a little bit to the left. So I'm going to come to this wire, and then when it's bold, meaning that the software recognizes it, right click, and then go scoot. Scoot, and it gives me this. Scoot means you can go along the wire only. You cannot go up and down. Even if you go with your mouse up and down, it's not gonna move. So I can move it a little bit to the right, and then the cursor changes. You can scoot more. So I'm gonna click on the other one and do the same. Now that's more readable. And you can do the same thing here as well if you want to. Like, for example, These, maybe they are too close, I can do the same thing. Again, you see, we got it, right click, scoot, and I can move it. And they can do the same thing here and then move it. And do the same thing for this guy and move it. If you want, don't have to, but it's good to know that you can make changes quite simply and without losing the electrical connectivity. You don't have to go through all these small details yourself. The software recognizes the electrical function. That's why it's called electrical. Okay, now, again, what I want to show you is, you've seen, of course, before how to set wire types. So you need to set wire types, and they are detailed here. Wire types, like for example, phase, the phases have different colors: red, yellow, and blue. And the control wires are brown, and the color is given. I think it's got number 15 in the instructions. And also, what about these? Schematic diagram, 3-phase motor, forward and reverse power. And this is just text. Why do I set text? Be very careful, guys. What did I say about text and measurements? Yes, you have to go to here and make sure you have paper space. Yeah, and then you select your scale model. And this is about what? About 1 to 10, I think. And say 1 to 10. You see, this is where it gets. 1/0.3 is 10/3. So it's 3 point something, 1 to 3, right? 1 to 2 is not going to do it. So it's 1 to 3. You can create a custom, as we did before, right? And call it 1 to 3. Just because you called it 1 to 3, it doesn't mean it's 1 to 3. Right? You have to set the scale here. That's just the name. It can be even your name. It doesn't matter as long as you know what it stands for. 1 to 3. I'll say okay. Okay. And let's choose it. Okay, that's reasonable. Now I can go here and then set the same scale for annotative scale, 1 to 3. And make sure you go back to the home page and set annotative scale text. Okay, let's go here and make it annotative. And you can set it what? To 2.5. Apply, close. Do the same thing for, we don't really do dimensions, but if you want, you can set dimensions to annotative as well. But now I can set my what is that? This is not good. 1 to 3. This is 2.5 millimeters, right? 2.5 millimeters is what? Inches here, because this is electrical. So electrical is what? Is imperial. So we can make it 1, which is 1 inch, which is 2.5. And the style, I think it's mentioned here. If you put it to Arial, we'll hit A. Look for Arial. Why there? And then apply, close. Let's try again. That is still too big. That is still too big. So we can go back and make it 0.5. Make it 0.5. Apply, close. Okay, let's look at the properties. 1 to 3 and line spacing 2.5, line spacing text. Paper text, 0.5 inches. Page setup. It's A4. So this is too big. This is way too big. All right, let's do something else. La 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 la. I'm going to leave this at 1:1 default. And this one will leave it without being annotative. And I still want it to be Arial. Yeah, that's more reasonable. Yeah. If you want to set it annotative, yes, you can, because you're actually controlling the size. And I suggest, don't do this until you're because later on you're going to need to scale it. So how to scale it? Scale, click somewhere, and let's say 1.2, for example, scale there, or 1.3. You can try. Okay, so as far as the line types and wire colors and so on, I'll leave you to that, and you can ask if you have any problems setting it. But what I want you to show you now, which we didn't do before, is wire numbers. Wire numbers on the schematic. We're going to do wire numbers. Wire numbers sequential, because you can see here the wire numbers. See these? 1, 2, 3, 4, 5, 6, 7, 8, and so on. Here's the 5. Why do you need wire numbers? Well, this is very important for wiring. Because if you look at a cabinet or you look at an installation, you don't just see wires. There are wires and they are tagged with wire numbers. So if you want to do troubleshooting, you want to see, okay, this wire goes from this point to that point. So what's going on? Also during installation, you don't install from memory. Your schematics shows you how to connect the wires from which terminal to what terminal. What's the tag number for that wire? So that's what you see here. Okay, so how do we do it? Okay, now we need to go sequential, and we can go project wide or drawing wide. I have one drawing only here, but I can go also project wide. So drawing wide, and there it is. Why did it not get number here? Because it has a tag. See, this tag prevented it from assigning it says, okay, there is already a tag for that wire. So what you can do is you can delete these and you can renumber. Wire numbers, sequential, drawing wide. There they are. What are these? These are terminals. These are square terminals. All right, now we need to do material. Mr. Mahmoud has got something. Where are we? Mr. Mahmoud, where is the chat? What? Where is my chat? Mr. Mahmoud is trying to say something, but it's not coming. Nope. I don't see the chat, Mr. Mahmoud. So you need to speak up through your microphone. Let me try something else here. Aywa. Okay. Oh, there we go. How do I do it, sir? Do what, sir? Can you do it again? Okay, well, this is being recorded, so you can look at the video later on or ask me a specific question. Don't just say how to do it. Do what? Do the wire numbers I just showed you twice. This is under schematic. There's wire numbers in the insert wires or wire numbers panel. Well, there. Now let's do the material list. How do we do the material list? Okay, I need to create another one. Right click on the project and then new drawing. Okay, one more time. Click on the project itself, then right click and then new drawing. Okay, and then we'll call it BOM, Bill of Materials. At this point, you leave the location. The template should be the same. You should see it, don't change anything. It has already copied what you have used before. And here you can say, I think, Bill of Materials. Okay, and you just say, okay. Do you want to apply project default values? Yeah, okay, no problem. Notice again what happened. Now I have there's my BOM. And this time it refreshed automatically. If it doesn't, what? You go to the green arrows and you do it. واضح? All right. Now let's create the report. You don't that schedule, you don't create it manually. It's done again automatically, provided you do all the material components complete. So we go to reports. And then go reports again. And then bill of materials is the default, so just leave it. And we'll say, okay. And then what do I have? I have actually two drawings. Simply you can say do all, or you can do just one drawing, because that's all. You can say do all, and then we'll say, okay. There's the material. Of course, I didn't put all the components. So it just shows me what? There's only motor. That's the only lookup I've done for this demo. But if you do all of them, you need to make sure you have a complete list of materials. And you say, put on drawing. Put on drawing. Insert new, yes. And then there's my as it stands now. And then you say close. There it is. Okay, now notice again, it's too small. So I can scale it. Scale it either with my mouse, like this, choose the base point, and then do it like that. Or you can hit, and then you say just also move, right? Move command. And there it is. Very nice, very readable. Okay, now notice something else. You can also control the font. So say okay, do all. And here we go. It's still the same. Let's see. Edit mode. Well, you can edit the table. Put on drawing. I see now it says update existing. See, sometimes if you create a materials list and then you find, oh, I forgot this component, it's not showing. You don't need to delete the previous table and create a new table. You just say update, leave it, because it actually knows you already have a table. So whatever changes you've made, it will take care of them. Okay, and just say okay, update, and that's fine. Close. Again, it's set back to the default size. I think you have enough information to do the whole thing. And I will go around and see if you have any questions. Okay? Anything else? I see, I think Mr. Firaz. The numbers, I showed you the numbers. I'll show you again, Mr. Firaz. Are you with me? The numbers, wire numbers. So we go back to this guy, and then wire numbers are here under schematic. Wire numbers, yeah, Mr. Mahmoud. Click it, make sure it's sequential. Sometimes you want to do line reference. What's line reference? It's a different way of numbering these. So for example, this will be 1, this will be 1A, 1B, 1C. So it's all belonging to the wire 1, except now it's going to be a line reference. 1A, 1B, 1C, 1, and so on. This one is sequential, 1, 2, 3, 4, and up until it finishes all the wires. So again, Mr. Mahmoud, we go wires, select sequential, project wide, or drawing wide. We have only one drawing, but there will be projects where we have more than one drawing. So you can do project wide. What project wide? It actually recognizes you've already used these in this drawing, so it continues in the next drawing with different numbers. So you don't have duplication of numbers, or of wire numbers. Okay, because here, even if I said project wide here, it doesn't really matter. Okay, you can just say, okay, start with 1. Yes, that's where I want to start. Even you can tell it which number to start with. And just say, okay, do all. Okay, and halas, it's done. You can see it actually create the wire numbers. Suppose the wire numbers are too small. Okay, let's right click, edit wire number, or you can go to properties. Properties right here. And then let's see, there must be a scale. Scale in the X direction, in the Y direction. So I can make this, just to exaggerate, 2 and 2. See how much bigger it was? So through the properties, you can control how big the wire numbers are. Well, you can make it 1.5, so it's readable. So when you print if it's readable, khalas. But in some drawings, you'll see that it actually comes out a little bit too small to read. So you can control it through the properties. Let's try here. Sequential format override use with layer. So you can look for it. I'm not aware of scale size in the command itself, but I can do a couple of these numbers at the same time, not just one at a time. Like for example, provided they have the same property. Now, if I go to properties and then change these 2 and 2, all of them will change. See, all of them will change. So you can choose them all together, one by one. But if you mix them, you don't get these. See, if I, for example, if I take this and there's a wire with it, and then go to properties, I won't get that. Because it doesn't know, you've mixed them. They don't have the same properties. It shows you only what's common between these two different objects. واضح? Mr. Mahmoud, is that clear? Okay, he's chatting again. Aywa. Yes, sir. Okay, good. All right, I'm gonna stop the recording and just walk around and see. Oh, let's just pause it and see if we want to pick up later on. So I'm just gonna pause the recording now.